Hi guys, welcome back. This is Ajit from Sri Venkateswara College of Engineering, and I belong to the branch of Electronics and Communication. For today's topic, it will be about bending glass, which is observed in fiber in the sense optical fiber. We'll be understanding and analyzing how to minimize the signal degradation in optical fibers in this presentation. And yeah, let's continue. As an introduction to our fiber optics, we can study the basis on which it acts on and how advantageous it is. For the how it works, it is like the light transmission. Fiber optic cables transfer data as light pulses through a thin glass core. They offer significantly high bandwidth than traditional copper cables, enabling faster transfer speeds, which is an advantage over copper cables and other traditional methods. What is fiber bending loss? Fiber bending loss occurs when light signal traveling through the fiber core are lost due to excessive bending. This happens due to the fiber alters the path of the light waves, causing them to leak out of the core. Causes of fiber bending loss. There are three main causes: sharp bends, repeated bending, and temperature variations. Abrupt bends and tight radii cause significant light leakage, leading to signal degradation. Even gradual bending can result in cumulative loss over time, especially with frequent cable flexing or movement. Temperature variations, in which the temperature can cause fibers to expand or contract, affecting their bending properties. Macro bending and micro bending are two types of bending losses. For the macro bending, this involves large-scale bending like curvature of cable wrapped around a spool. Micro bending refers to a small-scale bends, often caused by external pressure or imperfections in the cable structure. Factors affecting bending loss: fiber type, the core diameter, cladding material, and numerical aperture of the fiber influence its susceptibility to bending loss. Bend radius, the tightness of the bend directly affects the amount of light loss, with sharper bends leading to greater loss. Wavelength, different wavelengths of light can exhibit varying degrees of bending losses, with shorter wavelengths being more susceptible. Measuring the fiber bending loss can be measured using specialized equipment like optical time domain reflectometer and power meters. These instruments assess the signal strength and identify areas with high bending loss. Minimizing fiber bending loss, it can be done by proper routing, temperature control, and minimizing pressure. For proper routing, avoid tight bends and sharp angles. Use cable trays, conduit, and other management systems to maintain smooth curvature. Temperature control, maintain stable temperatures to minimize fiber expansion and contraction, reducing the risk of bending loss. For minimizing the pressure, avoid excessive external pressure on the cable, especially at the points where microbending can occur. These are the practical solutions for bending loss, such as microbending resistant cables, protective jackets and sleeves, bend insensitive fiber. Special fiber optic cables designed to withstand microbending are available, offering enhanced durability and reduced loss. There are protective jackets and sleeves that can be applied to critical areas of the cable to reduce bending loss by shielding the fiber from external pressure. BIF is a type of fiber that has a larger core diameter and a special cladding structure that makes it less susceptible to bending loss. The conclusions and key takeaways of bending loss in optical fiber is that to understand and minimize fiber bending loss is essential for reliable fiber optical communication. Proper cable routing, temperature control, and other use of specialized cables and protective measures can significantly reduce the signal degradation and ensure optimal performance. Thank you.